Okay, to start off our demo session, I'm going to first give you some sort of introduction of what I'm going to do later. So first, we're going to start off with our energy analysis. Okay, what we'll do is that we're going to have our model from Revit with all the setting that I wanted, with all the design that I wanted, and then I'm going to bring it over to Insight 360. So in Insight 360, which is a web application, I'll show you what you can do around it and why it is best to use it to analyze the building energy performance of your design. So by doing energy analysis, it can also show you the possibilities of making your design to be more efficient and sustainable. So it allows your design to be analyzed in terms of building energy performance, how well integration of the building form, system, and envelope perform under surrounding environmental condition. Okay, so this is the some sort of introduction of what we're going to do later. So we're going to have our model, our energy model to be computed and then send it into Insight 360. And then from there, we can actually compute and make decision on how we can further make it to be a more sustainable, to be more efficient energy using. Okay. And then next, we're going to conduct a solar analysis. So the function of solar analysis is to analyze how much of the sun energy hit your site or your building. So, but this analysis does not measure illuminance, which is the light level. So Revit actually let you perform two types of solar analysis. The first one is the solar study. Okay, this is something that available in Revit. So where you can actually visualize the sun part and shadow that a site or building element generate during a specific time. So you can also generate an animated study or a still image. Sorry. The next one, we have our solar analysis. So this is what we're going to do. So it visualize and quantify the distribution and intensity of solar radiation on Revit model surfaces. So the analysis considers shading by adjacent objects such as vegetation and surrounding building. So although not intended for sizing photovoltaic panel, solar analysis can help identify location for maximizing solar gain by considering shading effect and seasonal variation in solar radiation. So this is something that we're going to do a bit later. Okay, so 90% of building environmental impact come from the energy it uses during its lifetime. So you can actually reduce this impact by using renewable resources such as solar power. A passive design use energy that is already available like the sun, heat and light. If you use passive strategy effectively, you can downsize or even eliminate the cost of heating or air conditioning and save your money. So if the sun hit the building through its outer skin and window, good passive design can even turn the building into an energy asset. Okay. So this tool provides automated setting for specific study type as well as customizable option. Solar analysis uses surface on the model and a surface can be created from standard architecture element. For example, we have our wall, roof, floor and ceiling, or even if you have only conceptual meshes. So detailed geometry element type are not supported, including families such as generic model, group object, component, link object, and many other more. Okay, so the result for this geometry type will often lead to inaccurate results that are close to zero. So for that, what we're going to do later is that we're going to have our building element, a standard house from our sample project, and then we're going to run it for solar analysis. Okay, so this is it. So later we're going to have our sample project here, and then we're going to run a solar analysis so you can actually see how I do it, the step and the setting and everything. And then we're going to have a look onto the outcome, which is the solar penetration into our project. Okay, and then we're going to take a look on the lighting analysis. So you are typically trying to answer some fundamental question. which is including, can you improve the form of your building or room to actually get more natural light, or can you get enough light for specific tasks? For example, if you wanted your kitchen to be a little bit brighter, and then how much can you offset artificial light with daylight? Is light well distributed and not causing glare? So there are many ways to measure and visualize lights, and you may use different tools depending on which question that you are trying to answer. So some especially important notes that we're going to have a look is that good daylight comes from the sky and not from the sun directly. And when determining the light level for tiles in a building, we're going to measure the light falling onto the surface. Okay. So for daylighting analysis, it is good to do it on the early design process, where daylight feasibility analysis in BIM uh, should be conducted. Okay, so if you conduct this analysis at the beginning of your project, what can you do is that you can avoid glare. Okay, you can avoid the penetration of a direct sun into certain spaces. Okay, so often designer use previous experience and rule of thumb during these early phases. But when you are using BIM, you typically want to study conceptual room for their overall shape, aperture layout and size, and general shading strategy. So this later, when in the design process, you can really hone in the daylight to test for interior visual comfort. So this is where computer simulation and lighting consultant typically will come in. So often this work involves quickly testing different design parameters like shading feature, glazing properties, and window placement. So simulation results are usually calculated on a workplace based on a specific vantage point, which is our head height for a worker. Okay, so we're going to take a look into this just in the moment. Okay, so this is it. What we're going to do is that we're going to have our project here, and then we're going to run it for lighting analysis, which is what we're going to do is daylighting analysis, and then we're going to put in certain setting and everything, and then we're going to have our result. Okay, and lastly, this is something that I only wanted to let you guys know. We're not going to do any demo on this one. Lastly, we also have our cooling and heating load analysis, which is this analysis can be performed in both Revit and Insight. What it does is basically you model for your building design per usual, and then after space have been placed and defined for all area in the building model, you can assign these spaces to zone, and then you can perform a heating and cooling load analysis to actually determine the energy demand of the building and to determine space and zone requirement. So by doing this, what you do is that other than having a sustainable and efficient design, you also help to cost money and provide a highly comfortable design. Okay, so basically, you can actually do it straight from Revit. You do not need any any plugin to do so, and then you can just see it from your analyze tab. You have your heating and cooling load, and then you can just run your analysis from that.